Richard Gall is the king of sensory astringency, and he's got a couple of papers in the syllabus. This one was done at the University of Adelaide along with Lee Francis, who's a wonderful chemist there, and our old buddy Anita Oberholster, who's from South Africa but worked with the University of Adelaide and AWRI, the Australian Wine Research Institute, way back when. And they have this wonderful article about astringency and its causes and its chemistry. And so I recommend that to you. And then, following the lead of Ann Noble with the aroma wheel, they came up with a mouthfeel wheel, which you'll find described in the syllabus in pages 263 to 272. Here it is, and it's got a lot of terminology in it. So enjoy yourself looking at that one. What we did with OenoDev was to take a small number of these terms and try to create a useful vocabulary with 8 or 10 terms. So that's what I want to talk to you about here. This is really a translation from the French. I don't actually agree with all of the terms they came up with, but we were trying to sort of speak the same language. And I have found it very, very useful in tracking things like micro-ox and sensory aging. So here is your tongue. And when you make a red wine, you take it out of the fermenter the very first day, you're not going to have astringency all over the mouth. You're going to get green tannin. Now, I don't like the term green tannin. It implies that there are pyrazines present or maybe that it's underripe. It doesn't mean any of those things. It just means a grainy tannin that's on the tip of the tongue. And for my money, those are the co-pigmentation colloids that we've been talking about. Now, this is Michel Moutonnet, and he and Vern Singleton are the top phenolic chemists in the world. And I had the privilege of working with him. He was involved in the development of microoxygenation with Patrick Ducournau, and so I got to meet with him several times. Amazing guy, very kind, very smart. And so I asked him to explain to me why the theory didn't seem to work for me that young red wine would be bitter, but would not have astringency. And then as it got polymerized, it would get more and more astringent. Because that wasn't my observation. My observation was that it starts out really astringent, and then it gets softer over the course of a year or two. And then maybe later on it dries out and it does get astringent and kind of fall apart. But there was this period of softening that I think most winemakers see. So this is what he said. He said, what you're tasting are the copigmentation colloids. So here's an anthocyanin, and it's not soluble. It has to come into a colloid, but it's got a positive charge. So it's not going to form colloids with its fellow anthocyanins. We have to have these copigmenters to sort of space out the anthocyanins and intercalate in between them. And so we end up with a stack. And as they stack together, they start to form into a colloid driven together by the force of water. So we have a little bead there. And Roger Bolton had demonstrated that this was a one-to-one correspondence with no polymer involved. And that's important because that means you can't enhance color extraction with polymeric tannins like VR Supra, for example. It's got to be monomer, which is mostly means it has to come from grapes. So anyway, you've got this bead here, and then the protein can cooperatively bind to the surface of the copigmentation colloid, and that's what we call green tannin. I mean, perfect sense to me, and that's my working theory. So that's green tannin. And moving on, if we don't allow the wine to see any oxygen, then that graininess will migrate into the back end, and it actually goes throughout the mouth, in the cheeks, and all over the mouth. But I'm showing it here as underneath the tongue because dry tannin is the only kind of tannin that you ever see underneath the tongue, and it means that the wine is falling apart and has been deprived of oxygen. So if we let the wine see a little oxygen, and it might be something just as simple as barreling down, then instead of going in that direction, it's going to convert to hard tannin. This happens pretty quickly. It only takes a few days to go from completely green, grainy tannin on the tip of the tongue to this sheet-like tannin that's on the top of the palate, and it's very grippy, kind of makes your tongue stick to the roof of your mouth. And so sometimes we call it octopus tannin, and sometimes we call it peanut butter tannin. But there it is, and it goes, it's very angular all the way into the back here. So then the next step, which we can push along with microoxygenation or will happen naturally in the barrel, is that will get harder, and then it'll start to melt from the back. And so this is something that we call round tannin, because I don't know why we call it that. Tannin rond, it was the French's idea, but what it means is that it's grippy in the front and melted in the back. And that is the stage at which many French winemakers will then barrel down, because that hardness means longevity. And so they're looking for a wine that's partially resolved in this stage. If they want to push the wine to early release, they'll go ahead and bring some more oxygen and then melt it completely. Then you have a wine that doesn't have a lot of longevity potential, but is quite delicious in its youth. Now I want to add to this language the idea of wood tannin. And back to Richard Gall's group, I love their term. Wood tannin is quite drying, except we already have another use for that word. And so he decided to call it parching numbing. It's very fine here on the front half of the tongue, and it has eugenol in it, which is a topical anesthetic. And so the way you can tell the difference between that and grape tannin is that it's also numbing. This is the orange stuff that the dentist puts on your gums before he hits you with a Novocaine. And so wood tannin is a topical anesthetic. And so you end up with a sort of a donut or bagel-shaped ring of drying tannin with a numb spot in the middle. And so we call that parching numbing. And then just to complete the exercise here, I want to talk about minerality as another mouthfeel. Now, I am not talking about the smell of whetstone, which I call petrichor. I'm talking about a buzz in the finish that comes from living soil and certain types of bedrock, such as limestone, schist, and in California, we have a lot of volcanic ash and decomposed granite, and these all seem to impart this minerality, but we really can get minerality on any soil if we observe organic practices. And this is my friend Edmund Utley at Upland Estate in Wellington, South Africa. And he's showing off his very friable soil, sort of his earthworm city. We like to call these dirty pictures. And as you can see, he's got lots of cover crops. So that sensation that we call minerality is this energy in the finish. Many people mistake it for acidity, and it's associated with organic practices and sometimes sort of mysterious bouquet, particularly in sulfite-free wines, that we get this feeling of natural well-being. associated with minerality. And it also makes the wines age a long time. For now, I just wanted to locate that as another palate sensation that is in our lexicon of tannin nomenclature.